One of the most severe test procedures that can be done to test the lubricating power of an oil is with the cross-axis machine. This machine is standard equipment for lubrication manufacturers to test their products. With this test instrument, extreme pressure can be exerted on two metal surfaces while an oil bath attempts to protect the bearing surfaces. The shock test is the most severe of tests because it doesn't give the oil a chance to react. Shock tests can be produced on this machine by quickly pushing down on the torque wrench to create excessive friction. The ammeter will show how much friction is generated by measuring the amount of electricity used by the electric drive motor. Between each test, the race bearing will be carefully cleaned and polished, so each lubricant has the same opportunity to demonstrate its lubricating ability. A new test bearing will be used for each test. These bearings have the same metallic strength as the steel in piston rings, bearings, and other metal engine parts. The first product is a very popular engine oil. In just a few seconds, the oil breaks down and the bearing seizes. The motor is physically stopped. Watch the ammeter as the motor pulls more and more electricity to counteract the friction and heat. And the test bearing is severely damaged. There wasn't even a chance to try the shock test. After cleaning the machine, a second popular engine oil is tested. Synthetic oils are considered one of the best engine lubricants on the market today. Very quickly, the synthetic oil breaks down and leaves the metal bearing unprotected. Again, the failure of the lubricant creates so much friction that the electric drive motor is stopped. No shock tests here either. Again, the test bearing is severely damaged. The next test is on a very popular oil additive that uses plastic resins to build up a protective layer between engine parts. This additive provides no more protection than the other lubrication products. Amp readings go up. Friction causes extreme noise as the additive breaks down and the friction becomes so severe that the drive motor just stops. The bearings fuse together as they can in your engine. Just look at the damage on the test bearing. Now Bi-Tron is tested. The test conditions are the same. We will dilute Bi-Tron with a typical motor oil as it would be in an automobile engine. There's no noise, no smoke, and the drive motor pulls very little additional amperage. Even when the technician puts full force on the torque wrench and holds it down for as long as he can, Bi-Tron continues to work. Now for the shock test. Bi-Tron molecular engineering continues to protect the metal surfaces even under the most severe testing conditions. The shock test. Look at the test bearing. There is virtually no wear. In a more recent test, one oil additive widely promoted on TV infomercials was tested. You will see for yourself Bi-Tron's superiority. As with all other tests, the race bearing has been cleaned and a new test bearing installed. The additive is poured into the sump. As you can see, it fails almost instantly. Now let's try the same test with Bi-Tron. Again, the machine has been cleaned and a new test bearing installed. But let's make this test really hard. We'll pour water into the sump with Bi-Tron. Even with water added, Bi-Tron continues to lubricate, and look at the amp meter. To make this test even more difficult, dirt will be added to the Bi-Tron. Picture what would happen to your engine if water and dirt got into its oil. The oil would fail and the engine would be severely damaged. But with Bi-Tron protecting the metal surfaces, there is no noise, heat, or additional load placed on the drive motor. Just look at the amp meter. It is well within the normal range. Bi-Tron keeps protecting. Now the supply of lubricant is removed. Yet even with the shock test, it continues to perform. Bi-Tron keeps protecting. Compare the two test bearings. There's practically no damage to the Bi-Tron bearing, even with dirt and water added and the lubricant bath removed. This dramatic demonstration will show how Bi-Tron's molecular engineering works in your engine. Common lubricants quickly break down as pressure is applied to the metal surfaces and heat begins to build up. You can see the lubricant moves away from the pressure point, leaving the metal surfaces completely unprotected. Using the same technique with Bi-Tron, you can see the lubricant actually moves toward the hot spot, providing constant protection. Compare the four bearings just tested. Notice how much damage was done in the identical test. Only the Bi-Tron bearing did not suffer damage. In fact, it was actually improved by being polished. Bi-Tron will be tested against leading penetrating lubricant products on the cross-axis machine. One of the most popular penetrating lubricants is sprayed on the test bearing surface as pressure is applied. Quickly, the amp meter goes up. Friction and heat are generated and the lubricant fails. The amperage draw is very high. The test bearing is extremely damaged. Next, another popular penetrating lubricant is run through the same test. It does no better than the first. Only minimal force was applied, and yet it quickly fails. This test bearing is also severely scored. But when Bi-Tron is tested under identical conditions, the amp meter maintains its normal range. There is no noise and no amount of pressure on the torque wrench was able to break Bi-Tron's protective surface. The amperage draw is normal. Bi-Tron continually protects the metal surfaces with its molecular engineered formula that fuses to metal surfaces. When comparing these test bearings, again the difference is obvious. Bi-Tron is far superior to the other products.
Time after time and test after test, the products work.